Hello, this is the first chapter that we will cover in the Math Bridge 310 that goes into nursing math. What we're going to do in this chapter is just we're going to be reviewing some arithmetic. You are allowed a calculator, but it needs to be a basic type of calculator. Now, normally I have one in the classroom, and it turned out I didn't have one of these at home. You really want a calculator, a basic calculator that has a square root on it, which is the symbol that looks like this. This one does not have it. I couldn't find one like that. I've ordered one from Amazon for less than $4. It should be in tomorrow. So I shall have one by the time we need it in Chapter 6. But just a basic calculator, you're not allowed to use one of the more complicated ones. Okay? So the first thing we're talking about is decimal positions. We're going to be using decimals and fractions a whole lot in this class. So this first chapter is just kind of getting used to that. Okay? The first problem we have is we want to write 2.25 as a mixed number and then also as an improper fraction. Okay? Well, when you have a decimal like this number in front is going to be the whole part of the fraction, so it's going to be 2 and some fraction right here. And this fraction right here needs to be in lowest terms. Now, I expect a lot of you recognize the 0.25 is 1/4, but of course you're not always going to have ones that seem that easy to you. So what we do is we take the 2/5, and then we want to put it over whatever decimal point is last. Here I have 2 decimal points, 2 points after the decimal. So I go to 2 after, and that's called hundredths. So I put this over 100. And now to reduce this, both of these are divisible by 25. And then you end up with 1/4. Now, if you don't see that the largest number that you can divide by, that's fine. Divide by the number you see. Always check what you have and see if it can be reduced further. So 2.25 as a mixed number is 2 1/4. Okay, so that's the first part of this answer. We are also supposed to write it as an improper fraction, and that means that we will be ending up with just a single type of fraction, but the numerator will be larger than the denominator. And the way we do this, a lot of teachers call around the world. You take this times this plus this. So 4 times 2 plus 1. And that's going to be 8 plus 1, which is 9. So 2 1/4 is equivalent to 9 over, and whatever your denominator is here, that's what it is here. So your two answers are 2 1/4 and also 9/4. Example 2.1 is similar, although it's written in a different form. This is called ratio form. This is 6 to 18. Now, we can always write a ratio as a fraction. It's always the first one over the second one. So when I first convert this ratio into a fraction, I get 6/18. We're supposed to write it as an equivalent fraction in lowest terms. So we look at this and see if there's something that they are both divisible by. And these are both divisible by a 6. And then when we do that, 6 divided by 6 is 1. 18 divided by 6 is 3. So this answer will be 1/3. Okay. Example 1.3. We want to write the ratio 1 to 10 as an equivalent fraction with 120 in the denominator. So first thing we do is we write this ratio as a fraction, the first one over the second one. And we are supposed to rewrite this as something over 120. So this was in lowest terms, and now we're going to write it as something that is not in lowest terms. What you're going to do is you're going to ask yourself, what do you multiply this by to get to here? Well, 10 times 12 gives you 120. And if you're not sure, you can use your calculator. 120 divided by 10 is 12. So I'm going to multiply. If I multiply this by 12, I get 120. So I need to multiply the top by a 12 as well. 1 times 12 is 12. So the answer you're looking for is 12 over 120. Okay. Example 1.4. We want to write 5/2 as a decimal number. One thing to remember about fractions is that fractions are always division. What we call fractions are generally just fractions that divisions that don't work out perfectly for us. So all I have to do here to figure out what this is as a decimal is the top divided by the bottom. And we use our calculators for this. So I can do 5 divided by 2. Turn on my calculator and do 5 divided by 2 equals 2.5. So 2.5 is the number we are looking for. Okay, same thing here. We want to write 193 divided by 10 as a decimal number. Now when you're dividing by a 10 or some power of 10, so 10, 100, 1000, in short, if we are dividing by, turn the page over here, any of these, if we're dividing by 10, 100, 1000, or 10,000, then it ends up that we're just moving the decimal place back and forth. But it is still a division. So this is a special case, but it could be worked exactly the same way. I could do 193 divided by 10, which will give me 19.3. Okay, so what happens is you really are just moving the decimal place. So on 193, my original decimal place is right here. It's understood. If I'm dividing by 10, this has 1 0 on it. The decimal place moves over 1 place. If I were dividing by a 100 with 2 zeros, I would move it over 2 places. 1000 has 3 zeros, so I'd move it 3 places. But 19.3 is your answer. Okay. Example 1.6. I want to rewrite 9.25 over 100 as a decimal number. You can always do 9.25 divided by 100 on your calculator. Okay, so let's clear this and do 9.25 divided by 100, and we get 0.0925. I'm going to strongly recommend that you write the 0 before a decimal point. And that's mainly because if you don't, then if you're not careful, you'll lose the decimal point. It will look like just a stray mark. And if you do that, you can end up with dosages that are way wrong. You can end up killing somebody. Strongly encourage you to keep the number in front of a decimal point, even if it is a 0. And that's just for safety's sake. Now, how would we do this if we just wanted to think of it as moving the decimal? I'm going to write 9.25. I'm dividing by 100, so I'm going to move this decimal place 2 spots. That's 1, that's 2. Now, if I end up moving it more places than I have number digits written, those get filled in with zeros, which is exactly the same as this. Okay. So let's do 2 more, and then we'll go to another video. Look at 1.7 and 1.8. We need to look at them together, okay? And that's because there's a slight difference in these. These are both rounding problems. This one says round off this number to the nearest hundredth, and then the tenth, and then the whole number. This one says round down to the nearest hundredth, tenth, and whole number, okay? If you see round off, this is normal rounding, where if the digit you're looking at is a 5 or up, it goes up. If it's 4 or below, you round down. This is normal rounding, the stuff you learned whenever you first learned rounding, okay? Rounding down, you're always going to go down. It doesn't matter if it's 4.999999, it's going to go down to 4. Now, why would you use this? You use this a whole lot when you're talking about pediatric doses, and that's because the differences can be so small. You always want to dose lower rather than you run the risk of dosing too high. So this is especially in pediatric patients, okay? All right, so let's work this. Round off. I want to round off to the nearest hundredth. Okay, if I'm going to the hundredth, this is the 10th spot, this is the 100th spot. So my answer, when I'm rounding off to the nearest hundredth, is going to have 2 decimal places. Okay, now what we always look at is the number after. So for the 100th one, I'm going to look at 4.807, and I don't really have to worry about the 5. I want to round to this spot, so I look at the next digit over, 7. 7 is 5 or above, so I bump this number up. If I'm rounding to the nearest hundredth, I get 4.81. Okay. If I'm supposed to round to the nearest tenth, that's 1 decimal place. So I really need to look at 4.8, and then I need the 0 because I always look at the next digit over. Okay. This is a 0, which is 4 or below, so the 8 is going to stay the same. If you're rounding to the nearest tenth, you get 4.8. Now, if you're rounding to the nearest whole number, that means I want to get rid of the decimal entirely. So I want to round to this spot. I'm only going to have 1 digit. Okay, so I need that digit and then the one after. So I need 4.8 because I want to round to this spot. The 8 is larger than 5, so this one bumps up. The nearest whole number would be 5. Okay, compare that to 1.8. I want to round down to the nearest hundredth. So the nearest hundredth is that spot. We've actually got the same digits here. Okay, so I'm still looking at this part like I did for hundredths. But it does not matter what this digit is. This one's going to stay the same. So right here, even when I was rounding off, that 0 got bumped up to a 1. Here, it's going to stay a 0. So 4.80. It is important that you keep a 0 here. Mathematically, 4.80 is the same as 4.8. But this number tells you how accurate your measurement is. This tells you you rounded to the nearest hundredth. If you leave that off, it looks like you rounded to the nearest tenth, which is not as precise. You need to keep that 0. If I'm rounding to the nearest tenth, I want 1 decimal place. It doesn't matter what this number is. That one's staying the same. So the nearest tenth would be 4.8. And the nearest whole number, that's a 4. It does not matter that that is an 8. It rounds down to a 4. Okay, this is the end of part 1.